So before we write our first program, there are some instructions we need to take a look at, and we would look at the opcodes we would use in our program. For this first program, we need to be familiar with 7 opcodes, and we're going to take a look at them now. The first one is the move opcode. The move operation, what it does is that it moves data within the processor without accessing memory. And there are certain things you should know about the move operation. Not all data can be moved by this particular operation. The move cannot move more than 8-bit value. Also, the move cannot move to high registers. Remember, when we treated registers, we demarcated them into low registers and high registers. The move cannot move to high registers. Let's see an example of this. Let's say you have this instruction move R0 150. What this does is that it puts the value 150 in the register R0 and this immediate value, and as we know 150 is within the 8-bit barrier. Let's take another look at this example. Another example. Also, you can move one register into another, and what this does is that it moves the value of one register into the other and makes them equal in a sense. Move R1 R2 gives us R1 equals R2. It copies the value of R2 into R1. This is an incorrect example. Look at this, for instance. Move R0256, and we know immediate value is out of range. The largest number of 8-bit is 255. So something like this would cause an error, it wouldn't work. Another incorrect example is move R8 number 3, and as you can guess, R8 is a high register, so we cannot use this instruction on a high register, and we cannot use this instruction with values greater than 8-bit. The next instruction or opcode we're going to look at is the LDR, and what this means is load register. And what this does is it loads a register with either a 32-bit constant value or another register. It reads a 32-bit value from memory to register. Remember, the move, the one we just saw, just moves in the register. It cannot access memory. Load, on the other hand, can access memory, and it can access other values in the register as well. Let's take a look at this example. We have load R0 0xFFF, this hexadecimal value. What this does is that it loads this value into R0. And this another example, it's a bit different from the first one. Load R1 square bracket R2. We've not treated pointers, I know, but we'll talk about them when we start typing out stuff. Like I always say, yes, but this is to give you an overview so that when we type, you just remember we did this and oh, this is how it works. So what this means is that R1 is the value pointed to by R2. The instruction load R1 square bracket R2, meaning point R1 to the value in which R2, the value contained in R2. Let's say R2 contains the value 256. Then R1 starts pointing to 256, and yes, I know I said 256. Remember, we are using the load opcode, not the move. So 256 would work with load, but it wouldn't work with move. Remember, this one is 32-bit values, whilst the move is 8-bit values. Let's look at this other one. This is the store opcode, and what this does is that it stores a register value into memory. An example of this is store R0 R1. It stores the value of R0 into R1. Can you tell the difference? There is a bit of difference. It looks quite similar to the load. However, if you look carefully at the comment here, this one stores the value of R1 into R2 into, stores the value of R0 into R1, not the value of R1 into R0. With the store, the first register or the first operand is the source, and the second operand is the destination register. This is the opposite for the load opcode. So R0 into R1, it stores the value of R0 into R1. If we replace this with load, LDR R0 R1, R0 is going to be the destination and R1 is going to be the source. So please do remember this. A lot of people get confused by this. And the next one, instruction number 4, is the B instruction, and what this means is branch to a location. An example of this is B loop, and you should know this word loop is not a reserved word. It's a word that we give. It could have been B turn on or B go, B stop. This one branches. It branches to or jumps to loop. It's like there's a label in our program called loop. Remember we said we put labels by our instructions so that we can access them easily. Let's say there's a label somewhere called loop. If we invoke B loop, we jump there, and we would see an example of this when we start writing the code. Now we have number 5, BL, and this one is branch to a subroutine. BL turn on calls the turn on, and turn on is a subroutine. This is different from the B in the sense that the B jumps to one line instructions. To put it in simple terms, it jumps to an instruction location, whereas this one jumps to a subroutine. You can think of a subroutine as a block of code, perhaps like a function in a higher level language. It goes through a series of operations, not just one instruction. It goes through series and then goes back. So BL jumps to a subroutine and B jumps to an instruction, the location of an instruction. So we have the number 6. This is BXLR. Yes, they're just abbreviations. I know. We start typing them, they'll start making more sense. Yeah, just bear with me. This one returns the value from a subroutine call. An example of this is, let's say we have this subroutine called blue on. So we move the value 0x01, which is the value 1, we move it into R2, and then BXLR, meaning it returns the value to the function that was running before jumping to this subroutine. It returns the value after it's run this code. It keeps the value of R2 when it goes back to where it jumped from. Yes. So this one, as you can tell, would be used in conjunction with the BL, meaning when you enter the subroutine and the subroutine does its processes and it gets a value, you might want to take it back and then use that value. And what you invoke is the BXLR, returns from subroutine blue on. Yes. And this is the last one. This is the NOP, and it stands for no operation or do nothing, as it says here. For example, store R1, NOP stores the value of R0 into R1, do nothing for 2 cycles. 1 NOP equals 1 cycle. This is usually used for padding. If you want to give, perhaps you want to give time to some operation to perform and then jump to the next operation, you can pad it with a series of no operations. We would use it. In fact, we'll use this when we start. So these are the first 7 opcodes that we're going to be using. The first 7 instructions would have this in our program.